Today, we are going to dive into something absolutely fascinating, the malleable mind. We're going to look at how our whole relationship with our own brains has changed. We've gone from just kind of staring at its mysteries from the outside to literally reshaping it, and now even plugging it straight into machines. So, let's jump right in. Our story starts with this incredible phrase, islands of genius. What does that even mean? Well, it points to this deep neurological puzzle. Think of these tiny sparks of just unbelievable brilliance that can exist inside a sea of, well, profound disability. And this is not just some poetic metaphor, you guys. It's a real thing, and it might just hint at some kind of hidden potential that's locked away inside all of our brains. And that puzzle, it leads us straight into our first big topic, these spontaneous, almost unbelievable abilities that you find in something called savant syndrome. So what exactly is this condition? And more importantly, what can it teach us about what the human brain is really capable of? Okay, so savant syndrome. It's this really rare but totally fascinating condition. You often see it in people who have developmental disabilities. Actually, about half of all people with the syndrome also have autism. But what really makes it so mind-blowing is the contrast, right? You have this general limitation on one side and then this specific, off-the-charts talent on the other. It's a puzzle that has had scientists scratching their heads for centuries. And our obsession with this is nothing new. The very first time it was written up in a scientific journal was way back in 1783. So yeah, this isn't some new thing we just discovered. It actually took another 100 years for a doctor, J. Langdon Down, to give it an official name. And get this, the most extreme, the most brilliant cases, they're so rare. As of 2009, the estimate was that there were fewer than 100 of these prodigious savants in the entire world. Just think about that. So what do these islands of genius actually look like in practice? Well, one of the most common ones is music. And we're not just talking about being a little bit talented, no. This is the kind of thing where someone can play an instrument perfectly after hearing a complex song just one time. It's this innate, totally effortless musical genius. Then you've got mathematics. And again, this isn't about being good at your times tables. We're talking lightning-fast calculation, like instantly spotting prime numbers or crunching these massive sums in their head. And the craziest part? A lot of the time, they can't even explain how they do it. They don't consciously know the rules of math. They just know the answer. Another incredible skill is art. You have savants who can draw, paint, or sculpt with this stunning photorealistic accuracy, and they often do it completely from memory. They can capture these tiny little details that honestly most of us would never ever notice. Okay, this next one is really unique. Calendar calculation. Think about this. You could give them any date, past, present, future, doesn't matter, and they can instantly tell you what day of the week it was. Bam. Just like that. And finally, we've got visuospatial skills. This is wild. It could be someone who can measure a distance perfectly just by looking at it, or someone who can memorize a super complex map after just one single glance. It's like they have this built-in GPS and ruler in their mind. Now, here's where it gets really interesting. Some people aren't born with these skills. They actually acquire them, sometimes after a brain injury or an illness. And that raises a massive question, doesn't it? If this kind of genius can just suddenly pop up when the brain gets rewired by accident, could we learn how to do it ourselves on purpose? And that one question, that's our bridge from spontaneous genius to deliberate intentional practice. So for this next part, we're going to explore how an ancient practice, meditation, is now being backed up by modern science, proving it can physically, literally change your brain. The key idea to grab onto here is that your brain isn't set in stone. It's not fixed. The scientific term for this is neuroplasticity. And this is a huge deal because for the longest time we thought our brains just stopped growing after childhood. But we know now that's totally wrong. It means that with practices like meditation, we can actually be the architects of our own minds, building new pathways and forging new connections our entire life. And listen, this isn't something that takes a lifetime to achieve. Get this. One big study showed that people's brains had measurable physical changes after just 8 weeks. 8 weeks! In less than 2 months of practicing mindfulness meditation, the actual structure of their brains started to shift. That's incredible. And these changes aren't random. They happen in the parts of the brain that basically govern who we are. So you get more gray matter in your prefrontal cortex. That's your hub for emotional control and making good decisions. Your amygdala, which is kind of like the brain's alarm system or fear center, it actually shrinks and chills out a bit, which means less anxiety. And the hippocampus, the part for memory and learning, it gets stronger. We are literally rebuilding our own brains to be more focused and balanced. Okay, so we've established we can train our brains from the inside, right? Just by using our attention. But this leads to a pretty wild futuristic question. What if we could just skip the hard work of training? What if we could connect to our brains directly from the outside? And that question brings us right to the bleeding edge of technology. Our relationship with our own minds is heading into a whole new chapter. A chapter that's going to be defined by a direct link between our brains and artificial intelligence. So how does this stuff, a brain-computer interface, or BCI, even work? Well, it's kind of a three-step process. First, you've got sensors that read the electrical signals zipping around in your brain. Second, a really powerful AI, what they're calling a brain foundation model, figures out what those signals mean. It deciphers your intent. And finally, it turns that intent into a command for something on the outside, like a robotic arm or a computer. In other words, your thought becomes action. The promise here is it's just world-changing. I mean, just imagine giving a voice back to someone who's paralyzed just by translating their thoughts directly into speech, or letting someone control a robotic limb just as naturally as their own. And I have to say it again, this isn't science fiction anymore. This is happening right now. But, and this is a huge but, with that incredible promise comes some pretty immense peril. Because the same tech that can read our intentions could also be used to influence them. Think about it. An AI could be subtly steering your choices, nudging your behavior for the benefit of, say, a corporation. And it could all be happening completely beneath the level of your conscious awareness. So you have this stark contrast, right? And it presents the central challenge we are all facing right now. As we get this totally unprecedented power to read and even interact with the mind, one critical question just screams out. Who is going to protect our innermost thoughts? Okay, so for our final section, let's look at a proposed solution. Because as we're standing right on the edge of this new frontier, you've got legal experts and computer scientists arguing that we need a whole new contract for the mind, a new set of ethical and legal rules to manage this powerful technology. And the core of their idea comes down to this really powerful legal concept, fiduciary duty. Now, what is that? It's a legal and ethical duty to act only in another person's best interest, period. It's the same exact standard we expect from our doctors, who have to protect our health, or our lawyers, who have to guard our rights. It is literally the highest standard of trust that exists in our society. So the idea is pretty simple but profound. Just like your doctor has a fiduciary duty to protect your body and your private medical info, this proposal says that any AI connected to your brain must have a similar legally binding duty to protect your mind, to protect your cognitive liberty and your neural data. The AI's one and only job would be to look out for your well-being. So think about the journey we've been on. We started with these mysterious islands of genius. Then we saw how we can deliberately rewire our brains with something like meditation. And now we're on the verge of connecting our minds directly to AI. We are gaining an absolutely incredible, almost godlike power. And all of this leaves us with one final crucial question. As we learn how to rewrite the human mind, who do we trust to hold the pen?